Hello all, this is Mrs. Galazzi, and I'm back for a second part of our PowerPoint lesson starting with 9B. With this, you should now be able to get your 9B notes that I put in lesson plans, and you should be able to get those out of assignments or digital resources. So from now on, you should be able to always find everything that I upload in digital resources or assignments in your lesson plan area. Hopefully that'll make everything easier to find for you. If you cannot print the notes, then just take some hand notes, okay? I'm trying to help you as much as possible. I don't want to make it too difficult for you. So either take hand notes or go ahead and print off the notes, and there's blanks on there and areas to work your problems. If you can't print off the notes, my main thing would be to make sure you're working out the problems that I'm working out in the PowerPoint, because the working out the problems are going to help you with the worksheet that I assigned that is going to be due on Wednesday, April 22nd. Okay, so this is the worksheet that I gave you last week. You should be able to find that in assignments. And so this is the honor, so they have a little bit extra on the end, but you have percent composition, which we went over last week in 9A. And when we go over this stoichiometry, we went over it. This kind of stoichiometry is comparing like moles of calcium to mass of calcium. So this area, you're only comparing calcium with calcium or neon with neon. And so we're only staying on one side of this. We're going from mass to mole to atoms, atoms, mole, mass, and remembering that moles is that stepping stone between. So for the first part of your worksheet, we're just staying on one side. And this side is what I'm going to go over today, where we're actually crossing over from one substance compound to another, or one atom to another. So this is NaCl, sodium chloride, and formula units. So we're talking about Avogadro's number, and we're trying to find out how many moles of Na. And so when you do these problems, you're going to have a reaction formula that we need to use, and we're going from one side to the other. So this is completely different substances. You only stay on one side if you're talking about going from calcium to calcium. But if I'm going from here, sodium chloride, and I'm going to sodium, then I go ahead and cross over this bridge, which I will go over today in our PowerPoint. Okay, let me go ahead and change this back to the PowerPoint. Okay, so intro to stoichiometry, 9.7 notes is what 9B starts with. Stoichiometry, big word, mathematical relationships between reactants and products. And as I said, the first section, 9A, we just went over how to go from, mass to mole to atomic particles and then back. And this time we're going to have this one where we have two sides to this. And so we're going from mass to moles, and then we're crossing the bridge to another mole and going to mass, or Avogadro's number, 6.022 times 10 to the 23rd. So these are two different substances. If your problem tells you about two different substances, then we need to cross over this bridge, and we'll go over some problems. Okay, so this formula or reaction equation has P4 plus 5O2 reacts to form 2 P2O5. And I highlighted it yellow so you could see what I'm talking about as far as the area. There is 1 mole of P4 molecules. So when there's no number in front, that's just an understood one. 1 mole of P4, it reacts with 5 moles of O2. And when they react, they form 2 moles of P2O5 molecules. And so we're using these numbers as ratios. So this is a 1 to 5 ratio, to 2 ratio. So if I were comparing these two, 1 to 2, 1 to 5, so you can make different ratios depending on which area you're comparing. Okay, so we can use these ratios from the equation. If I wanted to compare P4 to O2, P4 to O2, well, it's a 1 to 5 ratio because there's a 1 mole here, 5 moles here, so 1 to 5. So when I'm writing it in a mathematical equation, I could do this ratio: 1 mole P4 over 5 moles of O2, 5 moles of O2 over 1 mole of P4. Say we were comparing P4 and P2O5. Well, we've got P4 here, 1, and P2O5 is a 2. So we've got a 1 to 2 ratio. So we could use the 1 mole P4 over 2 moles of P2O5 or reverse it. And lastly, we could also use O2, comparing it to P2O5. And so we've got O2 here with the 5 moles, comparing it to P2O5, 2. So it's a 5 mole O2 over 2 mole P2O5, or we could reverse it and flip it up the reciprocal. So that's how we do our ratios. We're just looking at the coefficients in the front of the reactions. Using the coefficients to make mole ratios, we can now convert the moles of one substance to another substance. So here's the middle of that chart I showed you earlier, moles to moles. So you look at what I'm given and you make a moles, you set it up, and then you do another problem, part of the problem where we're trying to go to, what are we desiring to find? And that would be moles. So this is the little condensed version of mole-to-mol. Okay, suppose a chemical engineer wanted to produce 25 moles of diphosphorus pentoxide. How many moles of phosphorus would he need to burn? And you're going to work out this problem on your notes. So we would use the ratios, okay? If we're looking at, did I write that? There we go. Okay, so I have the little formula here. Now, I know when I was growing up, word problems were a nightmare for me. And it was like, what are we trying to find out? So I'm going to try to help you eliminate that. I think on your notes, I underlined what you focus on. Okay. Suppose a chemical engineer wanted to produce 25 moles. So we are focusing on, this is our given. They have given us 25 moles. So this is what we're starting with. It says of diphosphorus pentoxide. So 25 moles of diphosphorus pentoxide is what we're starting out with. Now it's telling us what to find. How many moles of phosphorus would he need to burn? So now we're trying to find phosphorus. So we're comparing these two, right? And so we're doing 1 mole of P4, comparing it to 2 moles of P2O5. So we're going to need this ratio somewhere in the problem. So let me go ahead and work that out for you. Okay, so if we need, we've got the initial 25 moles, and we've got 25 moles of diphosphorus pentoxide. So this is what we're starting out with. So P2O5. Okay, so this is our given, where we're starting right here, up there. Okay, immediately, when we get it to moles, we can immediately go from one mole to the other. Okay, so since we have P2O5 in moles, all we got to do is cross over that bridge immediately and get to the next step, which is going to be moles of phosphorus is what we're trying to find. Okay. Okay, so remember in your last videos, if you watched last week, she told us to match our units, right? So we've got mole P2O5 over here. We're going to have mole P2O5 here, okay? Now all we're doing is, this is our bridge. This is our bridge up here, okay? This is our bridge. And so we're going to be using these ratios. Okay, so on top is P4. On the bottom is mole P2O5 because we had to match units. And so P4 is 1 mole. Remember, it's 1 mole. And then P2O5 is 2 moles. And we got this information from the reaction equation, okay? And so we're just calculating this now. And we have, the answer is obviously 25 divided by 2. Okay, if the 1 was a different number, we would multiply on top, but we only need to divide 25.0 moles divided by 2. And of course, that's going to be 12.5 moles of P4. Okay, so that is our answer for this problem. 12.5 moles P4. Okay, rounding. When we have starting, if we have only 3 significant digits, okay, she called them sig figs, 25.0, then our final answer can only have 3. So in the middle of the problem, we don't have to round, but at the end, we need to round to match our sig digs, okay? Okay, let's go ahead and go to the next slide. Okay, what if we wanted to see how much oxygen is required? So same problem as the last one, but now we're doing oxygen in P2O5. So we're comparing oxygen to P2O5. So let's go ahead and look at this problem. Okay, let's go ahead and look at this at this. Okay, so we're comparing now oxygen with P2O5. And so we're doing the same given as the last problem. It had 25.0 moles of P2O5. Okay. And remember our little step. We immediately, if we have it in moles, then we immediately go to moles of the other. Okay. And so we can do that. We're trying to find now moles of oxygen because it says, well, how much oxygen is required? So we're going to go moles of O2. Okay, and our ratio, we've got O2 on top, so we're going to use this right here. And we've got 5 moles, and remember this 5 came from here. Okay, 5 came from there. And then on the bottom, we're going to have 2 moles of P2O5. Okay, and these moles came from here. Okay, so when we have the second mole area and we're crossing over this bridge, we are going to look at our ratios in our reaction formula. Okay, so 25, we would multiply 25 times 5, and then we would divide it by 2. The way I do it on my calculator, I don't put anything in fractions or anything. I just go 25 times 5 equals, divided by 2 equals, the answer is 6.25 moles of O2. Okay, remember, always use your units. Numbers mean nothing if there are no units, okay? So you must always use units. Okay, let's go ahead and go to the next screen. Okay, now this one shows mass to moles. So we've got mass to moles, and we're going to cross over that bridge again. So they're adding this extra step. Now if we start in moles, or we could end start in mass or end in mass. But it shows you the moles is still that bridge in between getting to that mass. Okay, so this problem says if we are given information in grams or mass of one substance and want to go to another substance, we convert to moles first. So we always have to convert to moles first before we can cross over this bridge. Okay, so it says moles are the bridge between 2 different substances. Okay, let's go ahead and look at this problem. It says work out the problem on your worksheet so you know the problem. Okay, it has 1550 grams of phosphorus. This is our given. It says calculate the moles of diphosphorus pentoxide that result from burning 1550 grams of phosphorus. Okay, I'm giving you this reaction formula. You guys are getting off easy because the book actually gives it to you like this, and you have to figure out the reaction equation. And that's why I really emphasize knowing nomenclature, how to name compounds and write formula reactions. Very, very important. But since we got cut in class and we're on this unconventional way of teaching outside of class, I'm helping you out a little bit. Okay, so moles of diphosphorus pentoxide. We are trying to find this, and we are given 1550 grams of phosphorus. So we are comparing, for this one, we are comparing phosphorus, and we are comparing diphosphorus pentoxide. Okay, so this is our given, this is what we're trying to find. Okay, so we would set up first with our given. We've got 1550 grams of phosphorus. So we write P4 because P4 is the phosphorus. Okay, and then we would go to the next one. So we're starting here at mass. Our first step is going to moles of P4. So this side is P4. This side is going to be the P2O5. Okay, so we're going 1550 grams P4. First, we're going to go ahead and change it to moles of P4. And remember, the bottom has to match units. So we're actually doing grams of P4. Okay, because we start out with grams of P4. We've got to first convert it to moles of P4 in order to cross over that bridge and get to moles of P2O5. Okay, so if you remember in 9A, we talked about 1 mole of anything equals its mass on the periodic chart. Okay, so when we get to this mole, it's always 1 mole. Okay, when we're comparing the same substance, P4 with P4, then the mole is always a 1. Okay, so if they're the same, it's always a 1 for the mole. Now we got to go and look at the periodic table in order to get this number. It says 4 phosphorus. So what we're going to do is bring up the periodic table, and let's do a little bit of going in so we can see it. Okay, and so phosphorus is right here, 30.97. So 1 phosphorus is 30.97. We got to multiply that by 4 in order to get the total. Okay. Oh, I forgot about the good old saving thing, but I can't save it because it doesn't let me. Darn it. Okay, so we're going to start over. 15. Let me go ahead and bring this back up for you. Okay, so we've got 1550 grams of phosphorus. And we're going from grams to moles of phosphorus first. Okay, so we're going to moles of P4. And remember, that's a 1 because we're comparing P4 to grams of P4. So P4, P4, and we have to match grams of P4 on the bottom. That's how we know what order they go. Okay, and so phosphorus was 30.97, and that is times 4. So it is 123.88. Okay, 123.88 grams for P4 for phosphorus. Okay, once we've got to the moles of P4, now we're crossing over to the moles of P2O5. Okay, P2O5. So everything is on top. Notice we have the mass given. We go to the moles of P4, mass of P4 to moles of P4, and then we go to moles of P2O5. Okay, and just like the previous area right here where we had to match units, well, we've got to match these units down here. Okay, and so we're going to put mole of P4. Okay, so this is the bridge mole. This is the bridge mole. And Where we get this bridge mole information is from your reaction formula, okay? So mole P2O5 over here, we've got the 2, kind of covered up a little bit, sorry about that, 2. And then the P4 over here is 1, okay? Okay, so now that we've placed everything in, we've got 1550 grams P4 times 1 mole of P4 over 123.88 grams of P4, and then times 2 moles of P2O5 divided by 1 mole of P4. Okay, so how would I do this on my calculator? I would go from 1550 divided by 123.88, hit the equal sign, and then I would multiply by 2, and I would not worry about the ones because they wouldn't impact. So I would multiply by 2 and then hit equals again, and you come up with 25.0 moles of P2O5. Again, you must have units. They mean nothing if you don't have units. Okay, we're going to go ahead and stop with this video, give you a little chance to work on your worksheets some more. Try not to overwhelm you and put you too much throughout the day, okay? So I will have another video for you tomorrow so we can continue on in the notes and finish them. You guys take care, and I hope you're having some time of rest, but also some time of fun. I know it can get boring not being able to do very much, but I pray that you all stay safe and no one gets sick. And I really hope we kind of come back to school. I'd love to see you guys again. It is kind of lonely not seeing you guys. You guys take care, and I'll talk to you tomorrow for the next video.